Hello there, guys. This is the second version of the first example. I made an error. I thought I fixed it. It had something to do with the editing process, and I ended up bringing a value that was incorrect through the calculation. So I'm going to go through this really quick and fix this up with you, okay? As well as yeah, you'll see it's pretty straightforward. So if you had gone through the first video, basically I said we're going to calculate the confidence interval for the mean value of y for a given value of x, and basically we're going to, find the value for y prime at a given value of x, and then we're going to add and subtract some error. Now the error looks like this. Okay, the formula looks like this. The formula looks a little complicated, but it's really pretty straightforward. The t-value, we should know how to calculate t-value. The standard error, error of estimate, we've already calculated that from the previous class. Now it's just a question of working with this part of the equation. Well, looking at this part of the equation, well, first of all, the question was asking, calculate the confidence interval for the mean price of a car when the age is 6. Okay, so first thing we did was we calculated the value that we would expect when the age of a car is 6. So a car that's 6 years old should expect to have a price tag of about $8,035 and change. Now, we know that not all cars age 6 are going to have that exact value, so there's going to be some error on either side, and that's what our confidence interval actually calculates. So, like I said, we're going to calculate this extra factor here. And looking at our formula, this is what we would be plugging in. We have 13 data points. X squared is 948. X is 104. The average of the x's is 8 when you get that from your calculator. And we are interested when x is specifically 6. Piecing this into our calculation, we get the following. Now, the error that I got from the previous video was that I mixed the 4.8 and 8.4. So if this was 84 or 984, we would have gotten the exact value that the final calculation worked out to be. So that's where the error is. So here we go. We plug these values in, and in the end, we get the following. So I'll leave it up to you to make sure that you can do the calculation step by step, but I showed it here. And eventually, we get to here, 0.11405,836, and that's where the error was. So yeah, if you did the calculation with 984 minus 832, you would have gotten a totally different number. And like I said, I edited because I made the mistake, and then somehow it was a bit of a mess. Anyways, this is the value that we're gonna include, and so that's this value here. Okay, so putting this together, we would go to our table, our t-table with degrees of freedom n minus 2. So 11 is the degrees of freedom, confidence interval 95%. And when we look at our table, our t-table, 95%, degrees of freedom 11, 2.201. That's where we get that value from for the t-value. Right there it is. This we got from the previous class, standard error of estimate, which was right there. We did this last day. There's the calculation. There we go. It was right there. Okay, and I put that back into the formula. And this is the value that I incorrectly used last class, but here it is. Cranking this out. The total error is going to be $662.67 and change. Ultimately, we get this. We add and subtract that. And ultimately, we could say we are 95% confidence the average price, the mean price of all cars, right, is going to be, that are 6 years of age, is somewhere between here and here. The average. Now, we're talking all vehicles, right? So there's a fairly large spread between these two numbers, about $1,300, give or take, right? Hopefully that helps. Once again, I apologize for the error, and I will post this up with the other solution. Take care, guys.